Okay, student, now consider the problem on cell potential. Calculate the potential of the following cell at 25 degree Celsius. Okay, this is the problem. And Sn solid in contact to Sn2 plus ions, in contact to Ag plus ions, in contact to Ag solid. This is the cell. Okay. We have the given standard potential of the Sn oblique Sn2 plus ion is minus 0.136 volt, and standard potential of Ag plus oblique Ag is equal to 0.799 volt. Okay, this is the given in the cell. Now consider the cell reactions. Now consider the cell. Sn solid, vertical line Sn2 plus ions. It is also given the concentrations. Salt bridge Ag plus 0.015 with the concentrations. As single vertical line at the phase boundary Ag solid. Okay, this is the given cell. First write the cell reactions. Okay, first we have write the cell reactions. Here Sn is oxidized to Sn2 plus, and here Ag plus is reduced to Ag. That is the at anode left hand side electrode. Sn is oxidized to Sn2 plus, and Ag plus ions is reduced to Ag solid. Okay, so we have written now reactions at the LHE left hand electrode. Sn solid gives Sn2 plus ions 2 electrons. This is the oxidation's half reactions. Okay, we have discussed in the last video how to write the cell reaction. Okay, and at RHE right hand side, Ag plus is converted to Ag solid. Okay, so there is a reductions at a cathode. Now consider reductions at a cathode RHE right hand side. Ag plus 1 electron gives Ag solid. Reduction half reactions. Okay, here in first reaction there is a 2 electrons, and in second reduction half reaction is the 1 electrons. Okay, so balance the electron, multiply by 2 to the reduction half reaction, then we get the 2 electrons. Here also 2 electrons, the electrons are can be balanced. Okay, so multiply by the 2 reduction by the 2 reduction half reaction to balance the electrons. So we get the twice Ag plus 2 electrons gives twice Ag solid reduction half reactions. Now then the write the net cell reactions. We have written the writing the net cell reaction. So oxidation reactions is here. Sn solid plus gives Sn2 plus 2 electrons, oxidations half reactions, and reduction half reaction here twice Ag plus aqueous plus 2 electrons gives twice Ag, reduction half reactions. So there are cancel the 2 electrons are cancelled out. So we remain the left hand side Sn solid plus twice Ag aqueous gives on left hand side Sn2 plus aqueous plus twice Ag solid. Okay, and here n is equal to y n is equal to 2 electrons are released at the anode, and which is used for reduction at the cathode. So total electrons are 2. So n is equal to 2. First we have calculate the standard cell potential. So we have no formula of the standard cell potential. Standard cell potential is equal to standard potential of cathode minus standard potential of anode. Okay, standard potential of cathode and standard potential of the anode. So E standard is equal to standard potential of Ag plus ion Ag minus standard potential of the Sn oblique Sn2 ions. Okay, so standard cell potential is equal to, put the values of the cathode here, the Ag plus Ag is the cathode. So standard potential of the cathode is given. What is the standard potential of the Ag plus is the 0.799 volt. So right here 0.799 volt minus, because in formula there is a sign minus, minus in bracket minus. Why double minus? Because anode potential is the negative. So minus in bracket 0.136 volt. Okay, so we get the minus plus here, 0.799 plus 0.136. So we get the 0.935 volt. Okay, we get the standard cell potential 0.935 volt. This is the half problem. Okay, problem is solved. Here is half. The remaining problem we see in the next video. Okay.